All right, we'll finish up today's lesson with example 7. All right, so to do example 7, we're going to have to look at your data from example 4. All right, what we're going to do is we're going to calculate standard deviations above and below the mean. So for example 4, our mean was 44.65 and our standard deviation was 6.07. So we're going to go above and below the mean for these. So to calculate one standard deviation above the mean, just do your mean plus one standard deviation, and then we get 50.72. Then we do one standard deviation below the mean. That gives me 38.58. So two standard deviations above the mean is my mean plus 2 times your standard deviation, 2 times 6.07, and that gives me 56.79. Then we're going to go 2 standard deviations below the mean. So minus 2 times 6.07. And that gives us 32.51. All right. So I'm going to look down to part A, and it says, do all the values fall between 2 standard deviations of the mean? All right. So that means all of our data points from example 4 have to lie within here. All right, so that's basically what it's asking for numbers for part A. So the lowest number is 32.51, the highest is 56.79. Let's go up to example 4 real fast. Look at our data, and we have 32 right here, and that's below 32.51. So, boom, we're already done. So the answer is no. All right, 32 megawatt hours is more than 2 standard deviations below the mean. All right, and then for part B, in August, the mean daily requirement is 39.4 megawatt hours. Okay, so that's going to be my mean with a standard deviation of 3.2 megawatt hours. So this will be my sigma. The power company makes plans for any demand within 3 standard deviations. So that is 3 sigma of the mean. Will they be prepared for a demand of 51 megawatt hours? So we're going to figure out 3 standard deviations above the mean. So we're going to do x bar plus 3 sigma. So our mean is 39.4. plus 3 times 3.2. And this is going to give me 49 megawatt okay. So the answer for this is no. 51 is an outlier. Alright, so now last part we're going to find the z-score. So all the way back to the beginning, z-score is equal to the value minus the mean divided by the standard deviation. Okay, so this is my value. The standard deviation is 6, rounded up from the data in example 4. And our mean is 45. So a value of 61 minus 45 divided by 6. So our z-score for this data is 2.7, which is approximately our z-score. All right, so z-score is pretty easy. Just value minus the mean over sigma. All right, don't forget, Desmos helps us a lot with all this stuff.